Hey guys, can you hear me?
Yes,
Yes, I
Professor.
can.
I know you can't see me, but you can hear me, right?
Yes.
First off, everything went really well in the surgery. I'm doing great. All right. The only trouble is I just had a little setback today. I'm really getting cramping in my back. So literally speaking, I'm doing this from bed. Okay. So I really didn't think you needed to see my bedroom. All right. That's it. That's the first thing. Second thing, Mac needs some help. Guys, you can do it better than I can. Okay. Please, if you can, give him step-by-step directions on how you are uploading things into the notebook. The person that Mac chooses that tells me, the person that Mac tells me has done the most to get him online, that person will get 20 points, extra credit, okay? Fair enough, guys?
I put my full name, so if you guys go look for my email in the, that's my name.
Okay, there is a forum. Guys, there is a forum. There's a forum in the course. Just go to the modules portion, go to course content, go to the series of modules, go all the way down, and you'll find that there is a forum. Okay? All right, now, tell the truth. How many of you guys waited until this week to do the lab that was due last night?
You know I did.
I did it all on Monday.
Okay.
I took my break.
I understand that, but don't you remember my telling you that you were going to forget all this stuff? There's only about one or two of you guys that did it really, really well. The rest of you, the answer, by the way, was strontium iodide. What you should have seen in everybody pretty much got the strontium okay. That wasn't the problem. It was the iodide. And what you should have seen in the video is that all three of the solutions to which the iodide, to which the unknown was introduced, should have given a purple color. Okay? The purple color indicates that there was a reaction, that you were making I2. I2 creates the purple color. So from that information, you should have been able to match your unknown to I minus, and that should have been your that should have been your, what am I trying to say? That should have been how you identified it. Any questions, ladies and gentlemen? Remember that one of these things drops. The other thing I want to bring to your attention, once you create a good notebook, that doesn't preclude you from continuing to submit notebooks. You have to continue to submit notebooks or else you'll get a 0 for that notebook. Do I have your understanding on that, guys? I had 8 people submit notebooks. Okay, fairly easy lab. And really and truly, I'm really disappointed that you guys aren't going to see it because this is a fun lab. It's an active lab. And believe it or not, you get damn good results from it. And we're dealing with gas laws. Now, has anybody not had the gas laws yet? Finest kind. So we're going to start from the experiment, which is basically set up kind of like that. Okay. Are you seeing the slideshow, Madison? Shake your head, Madison.
Yes.
All right. Now, where you see the blue arrow, the blue arrow consists of a copper plug. And on the end of the copper plug, you kind of twist magnesium there. Okay. Now, you have this big long tube called a UDO tube. It is nothing more than a burette that is closed off on one end. Okay, so what you do is you fill the burette, the very bottom of the burette, with concentrated hydrochloric acid, and then you kind of carefully add water on top of that. The reason you're doing this is eventually you want the HCl to react with the magnesium. So once you fill the entire tube up, remember the bottom part's HCl, the top part is water. You invert the tube and you put the magnesium on this copper wire into it. Now, what happens is the magnesium fairly violently reacts with the HCl to make H2 gas. So the H2 gas bubbles up, and as it's bubbling up here, it collects in the top, and the pressure starts to force the level of the water down. Everybody with me so far? Now, you want to wait until all of the magnesium, is gone, because the magnesium is the limited reagent in this problem. The HCl is in excess. So once the Mg is gone, your reaction is over. Everybody with me so far? All right. Now, if you've all had the gas laws, then you know what the ideal gas law is. And that is basically PV equal nRT, or if I want to rearrange it, P times V, pressure times volume, divided by the number of moles, divided by the temperature, is equal to a constant. If we choose to use the constant 0.08206, then the pressure must be converted to atmospheres, volume must be in liters, temperature must be in Kelvin, and N must be in moles. Are we all good here, guys? Brian, give me a thumbs up. There we go. All right, now that would be all well and good, except there are some funky things that happen. The UDO tube is only semi-accurate. So before the experiment even starts, what you have to do is you have to standardize your UDO tube. So what you do is you put in an exact amount of water from a burette. The burette is accurate. The UDO tube is not. So you read what the burette reading is. In this case, I read my burette at 41.50 milliliters. I put it into my UDO tube. I read my UDO tube as 44.00 milliliters. Now, after I did my experiment, all my magnesium was gone, and I equilibrated my level inside the tube, UDO tube, with the level outside the UDO tube. The volume was 38.30 milliliters. I measured atmospheric pressure. That was 765 torr. The temperature was 26 torr. My water vapor pressure is 25.2 torr at 26 degrees Celsius. And the mass of my magnesium is 0.0331 grams. This is all the information I need to tell you what R should be. And I'm going to work these one parameter at a time. All right. The way this experiment is done, remember I said you inverted the tube, put that over the magnesium, and you put it in a pool of water. When you put it in a pool of water, there is the tube inside has like a level, and the pool has a different level. You guys know this because if you've ever been observant when you're drinking from a straw, as you suck it up, the volume inside the straw goes up towards your mouth, and when you let go of it, that volume goes back down. Do you all know what I'm talking about here? All right. Now, if the level inside the straw and the level of your soda are the same, that means the pressure inside the straw is the same as the pressure outside. We don't have a straw. We have a UDO tube. So when I maneuver this so that the level of the liquid inside the tube is the same as the level outside the tube, I know that the pressure inside is equal to the pressure outside. And we've already measured that. That, I believe, was 765 torr. But, guys, we collected it over water. So we got to account for the water vapor pressure. At 26 degrees Celsius, I go to a table and I find out that water vapor pressure is 25.2 torr. So I subtract that from the overall pressure in the room, which was 765, and I get 739.8. This is the pressure that is caused by the hydrogen that formed. Anybody have any questions about what I've said so far? Finest kind. Now I have that 739.8 torr. I need to convert that to atmospheres. So I multiply that by 1 atmosphere over 760 torr. Questions, guys? My pressure is done. Okay. Now remember, our UDO tube is not accurate, but our burette is. The original burette was 41.50. I put that into the UDO tube and it read 44.00. So I'm going to make a fudge factor. My volume for the burette was 41.50 to my volume UDO2 44. I divide those two numbers and I get 0.9432 is the volume in the burette, or the accurate volume, divided by 1 milliliter for my UDO tube volume. Now, when I maneuvered my UDO tube in the pool and I got the levels even, I was able to read what the level was on the UDO tube. That level was 38.30 milliliters. In order to get the true volume, I have to multiply that by the fudge factor. So the real milliliters is 38.30, the UDO tube reading, times my fudge factor of 0.9430. So my true reading is 36.12 milliliters. Again, I have to convert that to liters. So I multiply my milliliters by 1 liter over 1,000 milliliters. This means my volume is 0.03612. Any confusion thus far, guys? We're halfway there. Third reading, easy peasy. Temperature in the room was 26.0. In order to convert that to Kelvin, I have to add 273.15. So my temperature in Kelvin is 299.2. Now we have to figure out the moles of my hydrogen. Overall reaction. Magnesium reacts with HCl, 2 HCls, to make MgCl2 plus hydrogen gas. That's a balanced chemical reaction. So, stoichiometrically, my moles of Mg are equal to my moles of H2. I've weighed my magnesium. All I have to do is convert that to moles of magnesium. That is equal to moles of H2. I have all my values now. So if R is equal to PV over NT, I substitute in 0.9734 for the atmospheres, 0.03612 for the liters, divide that by 0.00136 moles, divide that again by 299.2 K. I do all that information and I get an R value of 0.0864. Generally speaking, guys, I usually get better results than that. You do know what the true value of R is, though. So if you know what the true value of R is, I need you to do a percent error. I believe it's called for in the report as well as in the notebook. Remember, percent error, real value minus experimental value, absolute value of that divided by the real value. So I got 0.0821 minus 0.0864 divided by 0.0821 times 100. I have a 5.24% error.
Are we given the real value of R in the student data?
Madison, what
Yes.
is R? What value, every time you did a problem, an ideal gas problem, what did you enter in for the value of R?
I don't remember.
Something like 0.08206.
Sure.
Okay. You have the value already.
Okay.
That is the value, 0.08206. But basically, what happens in the equation, again, this is a hint, guys. This is a hint. Look at all these numbers. 4 sig figs, 4 sig figs, 3 sig figs, 4 sig figs. How many sig figs is your value going to be?
3.
3 sig figs. You're limited. The weight that our balances are able to go out They only go out to 3 places past the decimal. So therefore, that limits your final answer for R out to 3 sig figs. Any question? Does this seem fairly simple, guys? Come on, Kara. It's not that bad.
Compared to what I was doing, no, this isn't bad.
This is a fairly simple thing, all right? Anybody have any questions on the results portion of this? Okay, let me go see if I can pull up the report. Nope, that's not it. There it is. Okay. Course content. If I remember it correctly, the only thing we have to worry about for the Postlab are ideal gas law problems, but don't hold me to that.
I have a question.
I'm here.
In the manual, there are 2 different procedures on doing it. One using
Yes.
12 molar and one using 6.
Yeah,
Which
I use the
one?
12 molar.
Okay, thank you.
It doesn't really matter. The only, you know, the difference is speed. The concentrated HCl works much faster. I think it works much better. And so that you see, there is a problem because you're working with 12 molar HCl. That's as concentrated as it gets. So there are some people that don't like to expose their students to danger. So they just make you use the half concentrated stuff. I like to use the concentrated stuff because there's chances of that little piece of magnesium floating away and getting into the pool. And if that happens, you got to start the whole thing over again. Anything else, guys? Are you seeing the slideshow? Thank you. Okay, show how the fudge factor, that has to do with the real value of the burette versus the value of the UDO tube. Show work. Put in your regular data. Room temperature in degrees Celsius, mass of the magnesium, total pressure. And guys, you're going to have to look up the vapor pressure of water. Easy enough, just Google vapor pressure of water and you should have a chart on there. Just look up your temperature on the chart and that will give you the vapor pressure of water. You may have to convert it to torr. Okay, volume of the H2 gas. That has to be converted. Basically, you read the UDO tube reading, multiply that by the fudge factor. Temperature in C, add the 273.15. Moles of H2, convert your grams of magnesium into moles of H2. Pressure of the dry H2 gas. It's basically the pressure of the atmosphere minus the water vapor pressure. Show how R is calculated. And that, ladies and gentlemen, is the whole result section. Questions?
When you said when you said show, it's like the other ones, like you want us to write down like the equation, like
I want you to show me how you got the number you calculated. In other words, the volume of the gas, you're going to have to show me the UDO tube reading, and you're going to have to show me that you multiply that by the fudge factor.
Okay.
For the temperature in Kelvin, room temperature plus 273.15. Are you understanding now?
Yes.
Okay. Any other questions from the results?
I see we have to find an average of the R values. Does that mean we have to do the standard deviation?
In the notebook, yes.
Okay.
Okay, so I'm looking for the Postlab for the gas laws, and I got it right here. Hold on one second. Shit, yes, tell her, did she email me? Yes, tell her she won't be marked absent. My bad. My bad. I told her I'd forget. Okay, Postlab. I don't know what I did, but I did something wrong. I think there are only 2 questions here, guys. Okay. Basically, first question, easy peasy. Give me a value of the gas law constant. Okay, I'm sorry. This is just a quick ideal gas law problem. You're given the gas law, you're given the temperature in Celsius, you're given the pressure in torr, and you are given the amount of hydrogen in grams. You got to convert all of these to liter atmosphere Kelvin moles and solve for liters. And the second one is just another problem that replicates what you did in the experiment. Any questions, guys? Okay, guys, that is basically it. Don't have anything more to say. I don't think it's that difficult. Had good success with this laboratory throughout the semesters. Remember, please, somebody get on the forum and somebody please help Mac out getting him to upload the lab notebooks.
I appreciate it. Thank you.
Anything else? Go ahead.
I wanted to ask you, I think I came out a little bit late, but you were saying something about going all the way, scrolling down, and then you will find something, and then like extra credit or something like that. I don't know if I misunderstood the stuff.
Victoria, the extra credit is you get on to the course site, you go into the forum, and you write step-by-step directions on how to upload an assignment into the notebook.
Okay.
You guys are better at that than I am. Mac is going to take the one that he uses to upload things into the notebook, and the person he uses, he's going to tell me, and that person will get 20 extra credit points.
Oh, okay.
Victoria, anything else?
No.
Madison, Kara, Mac, everybody. I really don't have anything more to say about this.
No, thank you.
If you want to sit and talk, we can.
Hopefully you feel better.
I'm going to feel better.
Rest well. We'll
It's
see you next week.
just a setback today. Everything up to this point was great.
I have a question about last lab.
Okay, thank you, Brian.
It's about the
The identification of it,
yeah, the anion.
of
You
course.
gave us the results for that part, right?
Yes.
So when I look at it, the BR matches the unknown, not the iodide. So how did you get iodide?
All right. I think, all right. I may be going back and regrading those. Okay. Uh, where did you find that, Brian?
So if you go to the PowerPoint for that section, so go to course content and then PowerPoint.
Thank you. That may explain why.
And then it's the last little slide in the PowerPoint.
Okay, PowerPoints.
Because I think the video actually says something different.
Okay, I'm going to shut right now. I'm going to pause the video because the longer this goes, the longer it's going to take. All right. Okay, I'm in the video, Brian.
I don't see.
All right.
And not the video, the powerful, the outline earth and hydrogens.
Your screen's frozen, I think. Or at least for me. I don't know if it's for everybody
Okay,
else.
stop share. You saying it now?
Yes.
It was like the one before the last one. So the answer we got was, oh my.
Okay, this was the example I gave you. Activity suit.
The last slide.
That is the last slide.
It is?
Maybe hold on a second. Okay, there we go.
Nope.
Professor.
I hope you
I'm
weren't
gonna go
using that one, guys.
No.
You said it in the video, but I rewatched the live. And you said in the video.
Yeah, you said in your video we should use your result.
You even changed the
No, I
name.
know.
of the
I know.
colors
I
for
know.
you to
Relax.
understand what colors
Relax, guys. I just have to find it. All right. This is the one I thought that you were talking about, but it's not true. All right.
that.
Cool enough. If you did bromine, you got credit. You're going to get credit for those points back. Okay.
All right, thank you.
Brian,
So
Brian, what happened was he changed the unknown on me.
Yeah.
All right. What I did last semester was I looked at what he did, and I made my observations on it because I knew that there were a couple funky things there.
Okay.
If you said bromine, you're going to get credit.
All right.
Anything else, ladies and gentlemen?
I have a question about the final.
Okay, Matt, go for it, Madison.
So is it just that we're gonna have to use formula from previous experiments to answer questions, or
Basically, like, for example, he may give you a weight of an antacid tablet. He may give you the titration of sodium hydroxide versus HCl. So you're going to have to standardize the base. And then from that standardized base, he's going to tell you how much HCl was added and how much NaOH was added. And you're going to have to determine the mass percent of the acid tablet. It's pretty much, Madison, it's pretty much recalculating what you've already calculated in the experiments.
Do you know if we're allowed a note card?
What's that?
Do you know if we're allowed like one index
You're
card?
allowed your notebook. Okay. Anything else, ladies and gentlemen?
I have a question about the pre-lab.
Okay.
Question 4. It asked for it in liters, and then I was just wondering if I did it, why I got it wrong.
Okay. Who's speaking?
Brian.
Okay, Brian.
Did you put liters per ET for the answer?
No, I just put L for like the units.
That's probably why.
Oh,
Yeah,
Maybe.
let me find it. Brian, your last name? There you
valence.
got it. Yeah. There, I found it. 1 or 2?
2.
Do you mind if I publish this?
No.
I don't even know if it's on the screen right now or not.
Does that mean we have to like multiply?
Question. Go back up.
What's that? Right above it?
Yeah, number 4. Oh, it's 30/21. So I was just way off.
Yeah, basically, your conversion factor is 0.83. So basically, all you have to do is multiply the 36.40 by 0.83, and that should get you. And even Brian, you can look at your result. Your results should be multiplying this by about 0.66.
Okay.
So you have to multiply the 36.40 by 0.3 to get your result.
Yeah, I divided it. That's what I got. All right. That makes
Okay,
sense.
don't do that on this, on the results today, okay?
Yeah.
Anything else, guys? Okay, I will fix that problem. I will give everybody credit for bromine, and we should be good then, okay, guys?
I didn't
Alright.
use the bromine. What if I didn't use the bromine? Is that okay?
What's that?
If I didn't use the one that we had in the PowerPoint, I used the one in the.
If you called it iodine, you got credit. I am not going to
Okay.
give credit for chlorine.
Okay.
All right, guys, I will see you next week then.
All right. Have a nice weekend.
You too.
Thank you.
Good night.
Good night.